The lever rule is used to interpret how much solid and liquid we expect at a given temperature in a material when dealing with the liquid region, or the amount of each chemical compound at the given temperature when we're not observing the liquid region. The lever rule will give us a mass fraction of each phase present. This is helpful for visual microstructure examination. In the phase diagram below, we can use the lever rule to calculate the fraction of ferrite or cementite in the 600 temperature region, or the amount of austenite and cementite in this region. Since the lever rule is like a ratio, let's consider this simple diagram below. This is our nominal value. To the left of it we have liquid, an amount of L over 3, and to the right, solid, an amount of 2L over 3. To use the lever rule to determine the amount of solid, we will take the length from the liquid side, L over 3, and divide it by the entire length, L. We have 33% solid phase. In the same manner, to determine the amount of liquid, we will take the solid section length, 2L over 3, divide it by the entire length, and we will get 66% liquid phase. We would like to consider the amount of liquid and alpha phase present at 1200 degrees C. To do this, we will measure the lengths on either side of the nominal value to the phase boundary line. Our length A is going to be 5.5 millimeters. And our length B is going to be 7 millimeters. Therefore, our total length is going to equal 12.5 millimeters. To determine the amount of solid present, we will take length A and divide it by the total amount. This is going to give us 44% solid, or alpha. Remember, we use length A, which is the length from the nominal value to the liquidus line. To determine the amount of liquid, we will use length B of 7, the distance from the nominal to the solid boundary line, again divided by our total, is going to give us 56% liquid. Now let's consider a 2.5 weight percent carbon steel that has been austenitized and allowed to cool. Let's consider it at two temperatures, 1000 degrees C and 600 degrees C. To use the lever rule in the austenite and cementite region, our length A will be the distance from the austenite boundary line to the 2.5 weight percent. And our length B is going to go to the cementite phase boundary line. Oh, 10.85. Therefore, to determine the amount of cementite present, we'll take length A over the total length, this is going to give us 18.7% cementite phase. And to determine the amount of austenite present, we'll take length B over the entire length. This is going to give us 81.3% austenite. Now we come down here to the 600-degree region. Our total length is going to be 17.3 centimeters. The distance from the ferrite boundary line to the nominal value, 6.5 centimeters. And our length B is going to be 11.8 centimeters. Our fraction of cementite present is going to be length A, 6.5 over 17.3 is going to give us 37.5%. And the fraction of ferrite present is going to come from length B, 11.8 over 17.3, which will give us 68.2% ferrite phase.